semester exam review. Number 13, fill in the blanks for the proof below. Given segment DA is parallel with segment YN, and segment DA is congruent to YN. Those two facts are also pictured on the illustration. So the first statement, segment DA is parallel to YN, that's given, as all first statements will be. Then it tells us that angle ADN, so let's highlight that. Start at A, trace D, and then go to N. So the middle is always the vertex. So here's the vertex. ADN is congruent to YND, which is here. The reason those two are congruent is because of the converse the alternate interior angles there. Not the converse, but it's those two angles are alternate interior angles. Then it says segment DA is congruent to YN. We saw that before as well. That was your given. Then it tells us that segment DN is congruent to segment DN. Segment DN is that line down the middle. So yes, of course it's going to be congruent and to both triangles because they share it. But since it's the same thing on both sides, it's like mirror image or a reflection. So this is the reflexive property. And then it tells us that triangle NDY is congruent to triangle DNA. And that is because of side angle side. That's one postulate that would work for this one. However, you have two sets of alternate interior angles. You also have this set here. So truthfully, it could be angle side angle as well. So it depends on our answer choices that you could have used that one as well. And lastly, it tells us that angle Y is congruent to angle A. And that is simply because corresponding parts of congruent triangles are congruent, also known as CPCTC. So in step 5, we mentioned that the triangles were congruent, so automatically, as soon as you know you have congruent triangles, the parts that are in the same spot will be corresponding, and they will too be congruent. Number 14 says, two sides of a triangle are 17 and 44. Write an inequality that describes all possible values for n, the third side of the triangle. So on this one, you probably would like to draw this triangle just to illustrate what is going on in the situation. You have one side as 17, one as 44, and the remaining side is n. To write the inequality, you need to find the low number and the high number for the boundary. To find the low number, you take the largest number, 44, and subtract the other number, 17. And that would give you 27. To find the high number in the boundary, the two numbers, 44 and 17, and you add them. So that would give you 61. So to write the inequality, we simply just put those two numbers we just described or figured out on the edges. So 27 less than n less than 61. Number 15 says, can a triangle have side lengths 8 inches, 12 inches, and 18 inches? And explain your answer. So on this one, I would take side 8, add side 12, and see if it's greater than 18. 8 and 12 make 20, which indeed is greater than 18. So that's true. Now take sides 12 and 18 and see if it's greater than 8. Well, 18 and 12 make 30, and again, that is greater than 8, so that works out. Now test the last pair, 8 and 18, and see if it's greater than 12. 8 and 18 would make 26, which again is greater than the third side. So then, yes, the triangle could have those measures because the sum of two sides will always be greater than the third. That is your reason. The sum of two sides will always be greater than the third. Number 16 says, are the two rectangles similar? And if they are, write the scale factor. So if they're similar, the sides should be proportional. The smallest side on the larger rectangle should be proportional with the smallest side on the small one, which is 24. And the larger side should be proportional. And then you should reduce those fractions or divide them to get a decimal and see if the decimal or the fractions match. So I know that 2 goes into 52 and 24. So when I divide both of those by 2, I would end up with 23. Oh, hold on. 26, sorry. Wait. 26 over 12, which again can reduce by 2 to give you 13 over 12. I mean, over 6. So in other words, 4 goes into both. Do the same thing on the right. If I take out 4 from 78, what would I have? $19.5. So I would have 19.5 over 9. Did I put 78? Let me double check. Just to be sure. 78 divided by 4. Yes, okay. So, since I didn't get the same fraction when I reduced by 4, I'm not going to get the same decimal either. So, at the end of the day, we would say no. They're not similar. Again, in order to be similar, these two should equal the same fraction when it's reduced. And since they don't, then they're not similar. Okie dokie. Number 17 would like for us to solve for x. So it would help a whole lot if we knew that these triangles were similar. First of all, and then we would have to assume, but let's assume that they are similar. So that means x is proportional to 4 and 8 is proportional to 6. So now we'll cross multiply and get 6x is equal to 32 and divide both sides by 6 and x is equal to a decimal. .33 repeating. Okay. And number 18 states, are the triangles in the figure similar? Explain your reason. So in order to be similar, one, we would need to know if these lines are parallel. So we would need to have arrows right here first. So we cannot assume they're similar if those aren't parallel. However, you can also pull them apart and compare proportional sides. So we could say 9 is to 12 as 6 is to 8 and reduce the fractions to see what it comes out to be. So this would be 3/4 equals 3/4. So since the sides are proportional, I would say yes, they are similar. But I'm going to have to double check on that one because I think those two sides have to be parallel first in order to validate the similarity. And again, I'm going to take a pause and resume recording